We continue our topic with sulfur and sulfuric acid. Here we have sulfur in yellow color. The formula is S. And here we have sulfuric acid or H2SO4 in a bottle. Sulfur mining. Sulfur can be obtained from the crater of volcanoes. Sulfur from underground is mined by frost process. We use hot compressed air and superheated steam that make the sulfur get out to the surface in molten state. Sulfuric acid is made by contact process. Sulfuric acid H2SO4 made from sulfur. Sulfur is converted into SO2, SO2 into SO3, and then SO3 into H2SO4. First, sulfur react with O2 to form SO2. The SO2 then burn further into SO3. This reaction actually is an equilibrium reaction. There are some conditions for this step. The first, the temperature is 450 degrees Celsius. The pressure is 1 to 2 atm and the catalyst is vanadium 5 oxide. The last step then dissolve SO3 in concentrated H2SO4 to produce H2S2O7. The H2S2O7 then dissolve in water to produce sulfuric acid H2SO4. You can do the question on page 241, number 9.19 until 9.22. We continue with 9.5 on your book, the chloralkali industry. There are some chloralkali process. The first is mercury cathode cell, and then diaphragm cell, and membrane cell. In mercury cathode cell, we use the material is brine and ACl concentrated solution and get in the cell. The cell use graphite or carbon or titan as the anode and mercury as the cathode. The product are hydrogen, NaOH, and chlorine. The sodium process add and dissolve in the flowing mercury Hg, the NaOH, then treated with water. The diaphragm cell, the cell use diaphragm made of asbestos. The same, the raw material is saturated brine or NaCl. The difference is in this cell, we use a diaphragm to separate the NaOH from Cl2 because there is a reaction between NaOH and Cl2 to produce NaCl, NaClO, and water. The product, the same, NaOH, H2, and Cl2. The last is membrane cell. This is the most modern system and it uses a selective ion exchange membrane to keep the product apart. The product chlorine, gas, hydrogen, and NaOH. We continue. Pure chlorine is a yellowish-green gas. The uses of chlorine. The first as cleaning pools and then as disinfectant or in organic chemistry or as chemical weapon during World War I because the gas is poisonous. The uses of chlorine for bleaching wood pulp required for the manufacture of paper and rayon, cotton and textiles, or in the extraction of gold and platinum, or in manufacture of dyes, drugs, and organic compounds such as CCl4 or carbon tetrachloride, CHCl3 or chloroform, DDT, refrigerants, etc., or in sterilizing drinking water, or as preparation of poisonous gases such as phosgene, COCl2, tear gas, CCl3NO2, mustard gas, ClCH2CH2SCH2CH2Cl, also used as insurgents against the local population and coalition forces in the Iraq War in the form of chlorine bombs on March 17, 2007. For example, 3 chlorine-filled trucks were detonated in the Anbar province, killing 2 and sickening over 350 people. Continue with the manufacture of lime or calcium oxide, CaO. The CaO we get from CaCO3 that is heated to produce CaO and CO2. The CaO then react with water to produce CaOH2. Actually, CaOH2 can react with CO2 to produce CaCO3. Uses of limestone, CaCO3. First, to neutralize acid soil and lake acidified by acid rain. Why? Because CaCO3 is a base or basic salt. Then the basic salt react with acid in soil. The acidity of soil is caused by acid rain. The acid rain itself caused by SO2 gas from the factory or industry that dissolve in rain to produce acid. So the rain is acidic. The second use is to make cement, powdered and mixed with gypsum. Gypsum is CaSO4 2H2O. This will create hard interblock mass of crystals of hydrated calcium aluminate or CaAlO2 times 2 and calcium silicate or CaSiO3. The fourth is to manufacture sodium carbonate or Na2CO3. The manufacture of lime or CaO. Lime or quicklime is calcium oxide and is produced by roasting limestone in a lime kiln. CaCO3 heated to produce calcium oxide and CO2. Uses of lime. First, in agriculture, to neutralize acid soils and to improve drainage in soils that contain a large amount of clay. It is used with sodium carbonate and sand in making glass. Large amounts of lime are converted into slag lime or hydrated lime. The formula is CaOH2. And the other use is in steel manufacturing, where it is used to remove impurities. Why? Because CaO is a basic oxide that will react with the impurities which is acidic, such as SiO2. The CaO that is basic react with acidic impurity such as SiO2 to produce salt. The salt of CaO and SiO2 is CaSiO3 or calcium silicate. The uses of CaOH2 slag lime. The first is to make bleaching powder. Can be as calcium hypochlorite, CaClO times 2, or as calcium oxychloride or CaOCl2. The second in making glass, the third for water purification, and then the other use. When mixed with sand gives mortar. When mixed with water, the mortar sets into strongly bonded material to hold bricks together. The CaOH2 react with CO2 to form CaCO3. The CaOH2 can react with chlorine to form CaCl2 or calcium oxychloride as bleaching powder. This one. Please do exercise. End of chapter 9, page 248 until 251. We'll continue with the next topic in another video.